As a surgeon and as someone who's taking care of patients with pancreas cancer, for example, the outcomes are very poor, as you can imagine. And so what we're trying to find is new discoveries or new treatments that can help these people, because essentially the patients are desperate, the community is desperate for new information, and I wanted to be a part of that. I wanted to contribute to that new research. My name is Kerry Smith. My research is focused on pancreas cancer. I'm a surgical oncologist.
I'm Kathy Lyons, and I'm an investigator in the Cancer Control Program here at Norris Cotton Cancer Center. And my clinical training is in occupational therapy, which means that I'm interested in people's ability to do the activities they want and need to do in life. And so in my research, I develop and test cancer rehabilitation interventions, where we're looking for ways to promote functional recovery during and after cancer treatment for adults and older adults.
I use yeast cells as a model system to try and understand how cells work. And that's quite far removed from people who are testing tumors in mice, let alone looking at tumors in humans. But there's a really important connection there, and a lot of important discoveries have been made in yeast and other model systems. And the ACS has a remarkable history of supporting experiments and projects in these kind of model systems that have led to real breakthroughs. My name is Jamie Mosley, and I'm in the biochemistry department. I consider myself a cell biologist.
My name is Jimmy Wu, and my research is focused mainly on developing a class of compounds called the Nuphar alkaloids. And these are molecules that can be found in the rhizomes of the common yellow water lily. We're interested in them because they have this unique ability of inducing apoptosis in certain lines of leukemia cells within 1 hour. That's incredibly fast. And apoptosis is this concept of programmed cell death.
My name is Todd Miller. I lead a breast cancer research-focused laboratory. I received the Research Scholar Grant from the ACS, which started in 2013. And that was essentially instrumental in sustaining my research program during the first formidable years.
The novelty in the research that we're doing here at Dartmouth-Hitchcock and at the Cancer Center is that we're taking small tissue biopsies and graft it, surgically transplant it into a mouse to grow the patient's tumor in the mouse. And we can study that, subject in a sense, the mouse to experimental treatments that you could never do to the patient, and see if the patient's tumor responds, find out more about the patient's tumor, the characteristics of the tumor that might be amenable to certain experimental treatments.
The current study that the American Cancer Society funded is a mentored research scholar grant, and I'm working with older adults who are either in treatment or completed their treatment and feel like it's really taken the wind out of their sails. They haven't bounced back the way they want to. They're struggling to do some of the activities that they want and need to do in their life. And it's actually a home-based treatment. I go out to their homes and we work on ways that they can get a little bit more active and set small goals to help them improve their activities.
So I study how cells make decisions, how they decide that it's time to divide or not divide, or to grow or not grow. And we're trying to understand this on a very basic level, because when these decisions go wrong, that's really what leads to cancers.
If we can understand how these molecules function, perhaps we can use that information and knowledge to develop new therapeutics, cancer therapies, for targeting cancer in a way that's different from what standard therapies can do right now. But in order to do that, we have to be able to make the compounds and synthesize them. And these are incredibly complex molecules from a structural perspective. And so what we're going to have to do is to develop new chemical methodologies and new reactions and then apply them to their syntheses.
The ACS is really unique, I would say, in terms of being able to support this broad range of experiments and projects.
Philanthropic funding for biomedical research is more important than it ever has been before, in particular because we are making huge advances in biomedical research and in cancer research, but the proportion of federal funding has not dramatically increased in recent years. So therefore, we rely more on philanthropy to be able to continue to make breakthroughs.
Every dollar that comes to our research program comes from the sweat and the passion of an ACS volunteer. And we take that very seriously, and we try hard to put that same sweat and passion into the research that money allows us to get to do.
Just keep it up and don't give up. Staying motivated and trying to help and do things, it's very valued.
And although we've made a lot of progress so far, there's still a lot of work to be done. So I encourage everyone who has already participated to continue participating, and for people who have not, to think about contributing in some way.
Knowing on a daily basis that my work is supported by the American Cancer Society and by individuals who are putting in their time for that is really an inspiration that reminds me what the big picture is of why we're doing what we're doing.